Hello students, I am Diptima Dehure. I am teaching you on the topic of 3-hinge arch. Let's start a problem on 3-hinge arch. What the question says, a 3-hinge arch of span 40 meter and rise 8 meter carries concentrated load of 200 kilonewton, 150 kilonewton at a distance of 8 meter and 16 meter from the left end, and an UDL of 50 kilonewton per meter on the right half of the span. Find the horizontal thrust. First of all, we draw the 3-hinge arch. Here one hinge is here A, and another hinge is B, and one hinge is C. It is denoted as C. Then what the question says, a span of 40 meter. The length of the span is 40 meter. Rise is 8 meter. This is the height. This is the rise is 8 meter. Carries a concentrated loads of, here two loads is acting 200 kilonewton, 150 kilonewton at a distance of 8 meter and 16 meter. Here this is the left half. Left end 200 kilonewton is 8 meter distance from the left end. 150 kilonewton each 16 meter distance from the left end, and an UDL of 50 kilonewton per meter on the right half of the span. On the right half of the span, it is 50 kilonewton per meter of uniformly distributed load is acting. Then find the horizontal thrust. Here the horizontal thrust is HA and HB. Here the hinge support A and B. Here the two unknown reactions are there, HA and VB. Here HA and VA, and at B point VB and HB. First of all, we calculate the support reaction. In support reaction, either we calculate moment at A equals to 0 or the moment at B equals to 0, but I am taking the moment at A equals to 0. Let's take the clockwise moment is equals to positive. How we calculate the moment? Moment is equals to perpendicular force into perpendicular distance. Here at A point, what are the different force? 200 kilonewton force, its perpendicular distance is 8 meter. Which calculating, it is clockwise, so it is positive. 150 kilonewton acting 16 meter distance, it is also clockwise, so it is positive. Plus, in case of UDL, I will calculate the moment, its force into its distance divided by 2. So 50 into its distance 20 into distance by 2 means it's half from A point, so plus 20 divided by 2, it is half plus another 20. Then it is also clockwise, so it is positive. And another vertical force VB into its perpendicular distance is 40, it is acting anti-clockwise, so it is negative, equals to 0. By solving this equation, we calculate the VB is equals to 850 kilonewton. Then after that, we find the summation of f of y equals to 0. In f of y, or taking all upward forces positive. For the upward force VA and VB, which is 850, and downward force is 200, 150, and UDL case load into distance 50 into 20, all are negative, which is acting downward. By solving this equation, we calculate VA is equals to 500 kilonewton. Then we calculate the horizontal thrust. In horizontal thrust, we taking the bending moment at C equals to 0. In taking bending moment at C equals to 0, either we taking the left half or we taking the right half. But I am taking the left half of this arch. In taking left half of the arch, we taking the all the clockwise force. Clockwise moment is positive and anti-clockwise negative. Here 500 kilonewton, 500 is VA. VA into its perpendicular distance. VA into perpendicular distance is 20. It is acting clockwise, so it is positive. And another force is 200. 200 into perpendicular distance. Here 20 minus 8, which is equals to 12. 2 minus 5 minus, this is acting anti-clockwise, so it is minus 200 into 12. Then 150 into this distance is 20, total distance is 20, this distance is 16, 20 minus 16, which is equals to 4. It is acting anti-clockwise, so it is negative. Then HA into its perpendicular distance, which is 8, equals to 0. HA is also acting anti-clockwise, so it is negative, equals to 0. By solving this equation, we will calculate the H is equals to 875 kilonewton. Due to symmetric, HA is equals to HB, which is equals to 875 kilonewton.